Okay, good day. This is Honors Algebra 2. I'm Mr. McCulley, and this is the video presentation for Section 4.1, an Introduction to Quadratic Equations. Let's get right to it. The learning goals for today, we are going to graph quadratic functions. We are going to interpret the maximum and minimum values of a quadratic function. So what, first off, is a quadratic function? A quadratic function is a polynomial function, and we've had some polynomial functions before. Most specifically the linear equation, and if you look right here, if we get rid of this first term, this ax term, all that we'll have left is bx plus c. Well, we've seen y equals bx plus c. That's a linear equation, y equals mx plus b. Now, most quadratic functions are nonlinear functions, and a quadratic function is also nonlinear. It has three terms, and so here is our first term, here is our second term, here is our third term. The ax squared term is called the quadratic term, and a is called the quadratic coefficient. Bx is the linear term, and b is the linear coefficient, and it is the linear term because its degree is 1. And c is the constant term. It's constant because it has no variable x to go with it, and therefore it does not change. The graph of a quadratic equation is called a parabola. The domain of a quadratic function is all real numbers, just like most linear equations have a domain of all real numbers. But the range is limited. And in a quadratic, there exists either an absolute maximum or an absolute minimum, so not all of the y values will be included. So what does that look like? If we have y equals ax squared plus bx plus c, then the y-intercept is always going to be 0c. Now, any y-intercept is always going to have a x value of 0 because it lies on the y-axis, and that is where x is equal to 0. And so if I plug 0 in, then I'll get 0. 0 times a is 0. If I plug in 0 for x here, b times 0 is 0, and all we'll have left is c. So this constant term is always going to be the y-intercept. The axis of symmetry is a line that splits a parabola into two symmetrical halves. So this purple dotted line right here is called our axis of symmetry. And then the vertex of the parabola is a maximum or minimum value of the parabola, and it lies on the axis of symmetry. The fact that the vertex, this point right here, lies on the axis of symmetry is very important when calculating either the axis of symmetry or the vertex. The axis of symmetry is a vertical line, and its equation is x equals negative b over 2a given y equals ax squared plus bx plus c. This a value right here matches up with this a value right here, and this b value matches up with this b value. So when you're calculating your axis of symmetry, all you have to do is make this value the opposite sign and then divide by 2 times whatever the a value is. The vertex lies on the axis of symmetry, so what you're going to do if you want to find the vertex, you're going to plug the value of the axis of symmetry into the quadratic function and label the ordered pair. So when I figure out what this value is, I plug that back into here. That'll give me the y value that corresponds to and I will show you that in an example shortly. The leading coefficient a, so this value right here that I've highlighted in yellow, has a big impact on the shape of the graph. If a is negative, then the graph goes down. If a is positive, then the graph opens up. If the absolute value of a is close to 0, then the graph will get wider. If the absolute value of a gets bigger, then the graph will get thinner. So let's take a look at that in a Desmos demonstration. So here I have a quadratic expression, y equals ax squared plus bx plus c. And a is equal to 1, b is equal to 0, c is equal to 0. So when I plug in 0, I get 0 out. And we can see if I make a smaller, if I get closer and closer to 0, we can see that the graph of the parabola is getting wider and wider. And the smaller that is, the closer it gets to 0, the wider this gets. Now if I bring it over and go closer and closer to 5, we can see that it will get thinner. So let's go back and set it back to 1. Now the b value, it does have an impact on the graph, but because if you remember, it is also part of this axis of symmetry. So if we slide it to the left, it moves the graph a little bit to the right. If we slide it to the right, it moves the graph a little bit to the left. And you'll notice that, and that makes sense because remember, what's happening first when you plug in B? You're going to make it negative. It would have an opposite effect of what you would expect to get in that case. Now if we move C, C is just a constant. It's going to have a translation effect up and down, and it's going to match those values. So if I go up to 10, it's going to move it up 10 units. And as I get closer to negative 10, it'll move it down negative 10 units. Domain and range. Since a quadratic function is a polynomial, the domain is all real numbers. And we're going to, in a later section, define all polynomials, domains of all real numbers. But since it is a quadratic function, it has a maximum or minimum value. The range is limited. So depending on the direction that the parabola opens, the range is either greater than or equal to the y value of the vertex, or the range is less than or equal to the y value of the vertex. So let's go back to the demonstration. And with all of these values 0, you'll notice right here, that is the lowest value in this function. So the domain of this red parabola is going to be all of the y values greater than or equal to 0. And if we move it up or down, we can see in this particular instance, when I have my c value at -5, this thing will have a domain of all real numbers, but its range will be values of y that are greater than or equal to 5. So some examples to finish. In this example, we're asked to find the y-intercept, the axis of symmetry, and the vertex of this function f of x equals x squared minus 6x plus 6. So we want to find the y-intercept. The y-intercept is always this constant value, and we know that because when we plug in 0 for x, this first term becomes 0, this second term becomes 0, and the final value that's left is just 8. The axis of symmetry. Remember the equation from the previous page, x equals -b over 2 times a. In this particular instance, our b value is already -6. We're going to plug in -6, which will be +6 over 2 times a. Now the leading coefficient of the x squared term is just going to be 1, so we're going to get 3 as our axis of symmetry. So x equals 3 is our axis of symmetry. Now finally, we want to find the vertex of this particular function. The vertex is found by taking the value of the axis of symmetry, and that is because the vertex lies on the axis of symmetry, so it will have the same x-coordinate. So we are going to plug in 3 into our function f of x, so we'll have 3 squared minus 6 times 3 plus 8, which will give me 9 minus 18 plus 8. So I will have -1 as my vertex. My vertex, in the final answer, will be 3, -1. Now we can use the Desmos to check that if we want. So we'll come back over to Desmos and we will close out all of these expressions. We will delete the a. We will make this -6. And we will make this thing 8 right there. And so we can see my vertex is at 3, -1. And if I go x equals to 3, like that, we have an axis of symmetry, and it looks as if I were to fold the screen along the green line, the left side of the red curve will line up with the right side of the red curve. State that the function has a maximum or minimum value and find that value, then state the domain and the range of the function. So what we want to do is we're eventually going to state the domain and the range, and we're going to say this and we'll go domain, and then we'll go range. So let's take a look at Desmos again and just go, we'll clear this one out and we'll just go y equals, we don't have to have it perfect, so 15 minus 5x squared. And let's change our window a little bit so that we have more on the y-axis. So let's make that a 10. I think that'll work. That will not work. So let's make it 25. There we go. So when we look at this thing, I look at that leading coefficient. Now, even though x squared comes second, the 15 is just the constant. This is the c value of this function. The negative 5 is the a value. And so since the a value is negative, this parabola opens down. So if I come back here, this function opens down because a is equal to negative 5. The domain, since it is a parabola, since it is a quadratic function, it is polynomial, and therefore the domain is all real numbers. Now the range. The range of any parabola is going to be limited. It won't be all real numbers. So if I look, clearly 20 is not graphed. And there is no way that I can get 20 out of this function. The biggest value that I can get, no matter what value for x I plug in here, I'm always going to get a positive when I square it. And then when I multiply by negative 5, it will become negative. So the smallest value for x squared is 0, and any other value that I choose for x is going to make it bigger. So the smallest that this can be is 0. So the biggest that y can be is 15, and clearly we can see when we click on that 0, 15 is that highest point. Any other point that I click on is going to have a smaller value. So what we're going to do to translate to the range is we're going to say the values of y that are less than or equal to 15. It's equal to 15 because, again, we do see 15 on that graph. Have our answer. Okay, last example. Mr. McCulley makes a Star Wars fan film for charity each year. Last year, 400 people attended the premiere, and the ticket price was $10 each. Mr. McCulley estimates that for each $1 increase in ticket price, 20 fewer people would attend. What ticket price would give the maximum revenue for the charity? Using that solution from part A, how much could the charity expect to make? All right, so how we're going to do this? Well, let's talk about last year first. If I were to talk about the profit from last year, I would say that I had 400 people at $10 each. 400 times 10 is $4,000. And so if I think about it, the profit for the charity, which we'll call C, would have been the number of tickets times the price. So C is going to be our profit for the charity. The T is the number of tickets. And little p is the price. All right, so our final answer can't be in three variables. It can only be in 2. And so what we're going to do is we're going to make x the change in ticket price. All right, and we'll say that that's in dollars. So my tickets, well, I started with 400, and it says that every time I change the price by $1, I lose 20 people. So in my final equation here, I start with the 400 people that attended, and then for every $1 change, 20 people will be subtracted. So if I make it $11, that will be a $1 change. So I'll only have 380 people attend. So that is my new number of tickets dependent upon how much I change the price. Well, the price here is going to be start at 10. And then if I want to make it bigger, I want to add the change in price. So we're going to add x to that. And so if I change the ticket price by 1, the new price would be 11, and the new number of people would be 380. Well, if I multiply that out, so let me do that. 400 times 10 is 4,000. 400 times x is 400x. Negative 20x times 10 is negative 200x, and then negative 20x times x is negative 20x squared. Now, when we simplify that, we get 4,000 plus 200x minus 20x squared. We know something about the graph of this particular function. We know that it is a parabola because of the x squared term. We know that it has a y-intercept of 4,000 because of the constant. And we know that because the a value, the value in front of the x squared, is negative, it opens down. So it almost has to look like this, where this point right here is 4,000, and this point right here is the change in ticket price, because that's what x is, so the change, and the maximum profit for charity. So we're looking for the vertex here. So let's go back to Desmos. Let's type that equation in. Let's go y equals 4,000 plus 200x minus 20x squared. Now when I look at that, I only see, because I know it's red because of the red over next to the 1, but I only see this little bit here. Clearly, we're not going to see a whole lot of this graph, and we know that's true because we took the time to kind of picture in our head what the graph was going to look like. The y-intercept is 4,000, and if we look at this graph, it only goes up to 10. So I'm going to click on this little graph settings ratchet here, and I'm going to change this to say 5,000. And now we're starting to see some things. Here we see it, and I can find that vertex just by clicking on that top value, and we see that when I raise the price by $5, my new profit will be 4,500. So here's what we're going to do. Let's take a look at this. What ticket price would give the maximum revenue for charity? $15 will give the maximum profit. Now you might say, hey, Mr. McCulley, wait a second. That's a 5. You said 15. You're making a mistake. Well, sometimes I do make mistakes, but not in this case. Remember, X is the change in ticket price. This is the ticket price. So if I get 5 for X, the new ticket price is 15. And then it says, how much could the charity expect to make? Well, we saw that in Desmos too. $4,500, and that is our set of final answers. And that's all I got for today, folks. Have a good one. Goodbye.